This is I want to explain distributed mutual exclusions. Mutual exclusion is nothing but only one process can enter into the critical sections. So what is in the critical section? So critical section is nothing but each and every process have some code segment. These code segments are used to access the SAD variable and SAD memory space. In the cooperating process, n number of process using the SAD variable and SAD memory space. So at only one time, one process can access the SAD variable and SAD memory space. That's called as distributed mutual exclusion. Okay, and then this is a mutual exclusion. First one, introduction in the mutual exclusion. So concurrent access of process to a shared resources or data executed in mutual exclusive manner. So only one process is allowed to execute the critical sections at any given time. In the critical section, only one process can enter into the critical section and execute the process at any given time. That's called as mutual exclusions. In a distributed systems, so SAD variable semaphore, SAD variable is nothing but a semaphore or a local kernel cannot be used to implement mutual exclusions. So message passing in the distributed environment, so message passing is very important. So two processes want to communicate means the help of passing the messages can communicate and coordinate their actions. So the sole means for implementing distributed mutual exclusion is nothing but message passing. So in that you have three approaches in the distributed mutual exclusion. First one is a token based approach, second one non-token based approach, third one quorum based approach. So token based approach is nothing but if any process want to come enter into the critical section means so based on the unique token it can enter into the critical sections. A unique token is shared among the sites. A site is allowed to enter its critical section if it process the token. So after processing the token, sending the, if any process want to communicate enter the critical section means send the unique token. This token is processed by the critical section and allow the process to enter into the critical sections. So mutual exclusion is censored because the token is unique. In the token based approach, so mutual exclusion is achieved based on the token is token. So because token is a unique ID, that's why we can achieve the mutual exclusion in the distributed mutual exclusion. Another one, non-token based approach. So non-token based approach is nothing but there is no token. So we are sending the messages to the process. So two or more successive rounds of messages are exchanged among the sites to determine which site will enter the critical section next. That's a non-token based approach. Another one is a quorum based approach. Quorum based approach is nothing but each site requests permission to execute the critical sections from the subset of all sites. In the each and every process have some subset of process. If any process want to enter the critical section, send the request permission within the subset of sites. That's called as a quorum. Okay, any two quorum contains a common sites. This common site is responsible to make sure that only one request executes the critical section at any time. That's called as a mutual exclusion. So in that we have preliminaries. A system consists of n sites S1, S2, n number of sites Sn. A site can be in one of the following three states. The sites may be first requesting the critical sections or executing the critical sections or neither executing nor neither requesting nor executing the sites. Then critical sections something about ideal of the critical sections. That's neither requesting nor executing the critical sections. And then requirements, we have three requirements. One is a first one safety property, and then liveness property, and then fairness. First one safety property. Only one process can execute the critical section at a time. That's called as a safety property. Also liveness property. State that the absence of deadlock is called a liveness property. So fairness property is nothing but each process gets a fair chance to execute the critical sections. Each and every process have a chance to execute the critical sections. That's all the requirements. So performance metrics in the distributed mutual exclusion. First one is message complexity. So message complexity is the n number of messages recorded for critical section execution by a site. So number of messages. First, I identify the number of messages to record the critical section execution by a site. Asynchronous, synchronous delay in the time record and before the next site enter into the critical section. That's called as a synchronization delay. Response time, the time interval a request waits for its critical section execution to be over after its request message have been sent out. The system throughput, the rate at which the system executes request for the critical sections. That means system throughput is nothing but 1 divided by synchronization delay plus average execution of critical section is called a system throughput. So in that we have Lamport algorithm. So Lamport algorithm is nothing but it's a message passing based on the mutual exclusions. That means if any process want to enter the critical section means based on the token based approach, send the request and then after getting the request it enter into the critical sections. The request for CS are executed in the increasing order of timestamps and time is determined by the logical clocks. If any process want to communicate means it's in the events, the event is determined by the logical class. Every site SI keeps a queue, then request queue which contains mutual exclusion requests ordered by their timestamps, and then the algorithm requires communication channel to deliver message the FIFO order. That's the Lamport algorithms. In there, requesting the critical sections. When a site SI wants to enter the critical section, it broadcasts the request message to the all other sites in the distributed computing, and then execute the critical sections. Site SI enter the critical section when the following two conditions must be hold. The first one, SI has received a message with the timestamp larger than TSI, I from all other sites, and then SI is request at the top of request queue. So releasing the critical section is nothing but site SI upon exiting the critical section removes it request from the top of the states, top of its request queue and broadcast the timestamp release message to all other sites. And that we have in the Lamport algorithm also we have drawbacks. It's unreliable approach and also high message complexity. The message complexity based on 3 types of messages. That means 3n-1 message complexity versus n-1 request messages, and then n-1 reply messages, and then n-1 release message. These are the message complexity in Lamport algorithms. There see the diagram for the Lamport mutual exclusion algorithm, and then we have process P1, P2, P3, 3 process, and then P3 want to enter the critical sections. That means it sends the request message to the P21, P1. So after sending the P3 process request, and again, so P1 can send the request message to the P21, P3. That means it want to continue its check the conditions. The critical section is free means idle means the process can enter the critical section and complete its execution. In that, whenever it's sending the request or reply or any messages, it's send the timestamp. TS is nothing but timestamp, and 1 is nothing but events, and then P3 is nothing but a destination source events. In that process, P3 want to enter the critical section means it sends the request to the both B21, B1, and also it sends the request with the timestamp TS, 1, P3, and then again after sending the P3 request, and then P1 also send the request message to the both B21, P3. Here we have timestamp TS, T, P1. So TS, T, P1. In that in the queue have top we have TS, P1, P3. That means so P3 can enter into the critical sections. That means P1 and P2 send the release message to the critical section. After executing the critical section, it send the release message to the both P21, P1, all other sites in the process P1 and P2. So after executing the critical sections, to release the release message to the remaining release message for the remaining process. This is about the lab after here after P3 send the release message to the both P2 and P1. So P2 there is no request, and then P1 can execute enter into the critical sections. That's called as a Lamport mutual exclusion algorithm. So example for Lamport's mutual exclusion algorithm, we have send the request and the release message, and then reply message. We have 3 types of messages, and then after getting the reply messages, the process can enter into the critical section. After that, after executing its critical section, it send the release message to the all the other process. That's a Lamport mutual exclusion algorithm. So, okay, thank you.